Hi everyone. I want to thank you for joining our webinar today, Deploying Applications on Kubernetes and Oracle Cloud using Bitnami's tools. I am your host, Mavian Ruiz, Bitnami's Partner Marketing Manager, and with us today we have Sebastien Goasguen, our Senior Director of Cloud Technologies, as well as the author of the Docker Cookbook. So as a high-level agenda of what we're going to be covering, for anyone who hasn't joined us before, we're going to be covering who is Bitnami, giving you a little bit of information about our Bitnami-based containers. We'll give you some information on what is Kubernetes and the benefits of using Kubernetes on the Oracle Cloud. And Sebastien will give you a run-through of Bitnami's container tools, Helm, Monocular, and Cublas, as well as running through a demonstration of them as well on Oracle Cloud. For anyone that might have any questions, feel free to use the WebEx chat window in order to ask, and I will go ahead and moderate those within a live Q&A with Sebastien towards the end. And then with that, I will go ahead and give the presentation ball over to Sebastien.
Hello, everyone. My name is Sebastien. I'm the Director of Cloud Technologies at Bitnami. I'm in charge specifically of all things Kubernetes, and that's what we're going to talk about today. We're going to talk about Kubernetes and then how it plays with Oracle Cloud. So what is Bitnami? You may have heard of us. We're very well known for all the marketplaces that you can find on multiple clouds like AWS, like Google Cloud, and of course Oracle Cloud. So we have over 10 years of expertise tracking, packaging, compiling, and delivering application to any cloud and for any formats. So here you see on this slide, over 150 apps, over 1 million deployments of virtual machines on different clouds all over the world, and we have a very advanced catalog of application from, Node.js, Drupal, Joomla, Jenkins, you name it. We have, lots of open source applications that we track and that we deliver. So we are all about application delivery, application packaging, and then running in production. Of course, now that applications are going towards containers, we are also packaging containers. And for us, containers are just a new packaging format. So we have all those containers that you can find on GitHub. You can, look at them, look at how we build them, and see what we package in our containers, and you can definitely use them. We have two different types of containers. Some of them, we call them development containers. You use them on your local machine to start developing an application. And basically, those development containers, they give you all the scaffolding that you need to start building your application. And then we have, a lot of application containers, things like Redis, MariaDB, Memcached, MongoDB, and so on, that you need, in addition to be able to run your application. So all our containers are built routinely with the same tool chain that we use to publish applications to the Oracle Cloud. So when you use our containers, you're using the same application that we build the same way than the ones that you can find on the Oracle Cloud. The only difference is just the packaging, okay? And containers are very much a new application packaging format, okay? So, in short, Bitnami, I added this slide here. We are definitely seeing that application formats are evolving. We started with bare metal not so long ago, okay? And then, virtual machine appeared maybe the mid-2000s when VMware started, getting extremely pervasive in the data center. And then the cloud arrived with, of course, Amazon EC2 and Oracle. And now we have containers. And of course, you need something to manage all those containers. That's where Kubernetes comes in. And Kubernetes is also coming up with their way of packaging applications. So we're going to see Kubernetes packages. And, if you pay attention to the latest evolution in application design, you probably have heard about serverless. So at some point, we're going to see applications that are based on serverless paradigm. And the challenge that we're all facing is that, how do we survive this evolution? How do we migrate from bare metal to VM, to cloud, to containers, and then, potentially serverless? We cannot possibly change all our pipelines every time that a new format comes into play, every time there is a new package coming into play. So at Bitnami, what we do is that we allow you to move toward, through this evolution and address all those different packages. So if you still have bare metal, we can do bare metal. If you want to do cloud, we can publish to your cloud. If you need serverless, we actually have a serverless solution that we're going to present today. So what we see is that we want to be with you, everywhere, all along the spectrum, whatever the application, shape, whatever the package, and then we want to help you deliver those applications, okay, to your operation. So in brief, that's what Bitnami does. So definitely check, a little bit further what we do. So now Kubernetes and Kubernetes on Oracle Cloud. So you most likely have heard about Docker and how it's helped really rejuvenate containers, because containers were not new. Containers were originally in the Linux kernel with LXC, but Docker really, by bringing a new experience, a new user experience, Docker really boosted the container ecosystem and actually created a container ecosystem that didn't exist. And this has really fueled the rejuvenation of using containers to package your application. The one thing that Docker didn't really address is that once you start wanting to move to production and you want to run all those containers in your data center, now you're talking about running containers across, at least dozens, maybe hundreds, maybe thousands or 10,000s of hosts. Let's say 100 or 1,000 hosts, medium size. You're going to need a system to manage those containers that are distributed across your data center. And when Docker came up, there was no system to manage all those containers, to orchestrate all those containers, making sure that they were going to be able to talk to each other, making sure that you would have like a way to reach those containers even if they go up and down, making sure that you would have a way to discover those containers. So Docker was very much a single machine developer tool. Okay. Soon after, maybe I think it was 2015, December 2015, they announced Docker Swarm, which was their first attempt at coming up with an orchestrator for containers, something that allowed you to actually manage containers on a cluster of servers. Okay. But at the same time, there was also another system that came up, maybe couple months before, maybe I think June 2015. Kubernetes came up. Kubernetes is Greek. Okay, it's a Greek word for helmsman. At the helm of the ship, the captain of the ship. So it's the entire nautical theme of containers that you put on top of a ship and that you move across the ocean. So Kubernetes is Greek for the helmsman. It's an open source system for basically managing containers. And Docker and Docker Swarm come from Docker Inc., but Kubernetes is also open source, and Kubernetes comes from Google. Kubernetes is very much a rewrite, an entire rewrite in the open of the internal system used by Google to manage containers. That system is called Borg, and if you Google for Google Borg containers Kubernetes, you'll most likely find a very well-known Borg paper. So a lot of people talk about the Borg paper, which is a paper that describes how Google manages their application in their own data centers. Okay, so Kubernetes is not Borg. Okay, Google didn't open source Borg. Kubernetes is very much a new software that's been written as open source from scratch, but all the thinking that you see in Kubernetes, all the architecture, all the API, and so on, is inspired by the 15 years that Google has with operating containers at scale. And when you're thinking about distributed applications, you have to think about, Gmail, YouTube, Google Apps, all the Google apps, even GCE, even the Google Cloud. All these applications are distributed applications that run inside Google data centers, and those distributed applications are managed by Borg. So now, when time comes to choose what system you're going to use to manage your containers at scale in your own data center or on Oracle Cloud, it makes total sense to, look at Kubernetes. And I'm not going to do one-to-one comparison between Kubernetes and Swarm, but here, I just put a few words. The API of Kubernetes is extremely rich. It's one of the reasons why I embarked on Kubernetes even before I joined Bitnami. I launched a startup entirely focused on Kubernetes, and then we got acquired by Bitnami for this Kubernetes knowledge. So really, I really enjoyed the API of Kubernetes, and then I'm going to show you a little bit of that. And then you got things like cluster federation, role-based access control, quotas, network policies. All these very rich features are actually out of the box inside Kubernetes. So when you install Kubernetes, you have quotas. You have role-based access control. You have network policies if you want to isolate, different namespaces and so on. And you have federation. So it's an extremely rich API, and it's a very feature-rich system. And just one thing to convince you, it is the fastest growing project on GitHub. I mean, we can argue about like metrics and things like this, but if it's not the fastest, it's like the second fastest, or maybe the third fastest. It depends what metrics you look at. So the Kubernetes community is booming, and it is a very rich system. So, before looking at the Oracle Cloud, and I'm going to actually jump into demos because it's going to be, more interesting than slides. So, stick around. I'm actually going to show you how to use this. But let's look at the architecture briefly here. Kubernetes is actually a fairly traditional setup. You have a master node or a head node. That's the green box that you see on the screen. And then you have a set of nodes, worker nodes. That's the blue boxes at the bottom. And each box, each system runs a set of agents. So the head node in green runs an API server, runs a scheduler, and a controller manager. Those are the three main processes of the master node. And it also needs a database of sorts to store states. So to have a scalable, fault-tolerant storage system, Kubernetes is using something called etcd. Okay, it's let's call it the new Zookeeper. Okay, if you know Zookeeper from Mesos, Zookeeper that's being used in Mesos, and Zookeeper is an Apache project. etcd is basically the new Mesos. It's a distributed key value store written in Go, and that gives you very good fault tolerance. And in blue, you have your nodes. What do you have running on your nodes? You have the Kubernetes agent, a kubelet. So it's pretty much a service that runs. That's called kubelet. So it's a binary that runs like this, that talks with the API server on the head node. And then you also have something called the kube proxy. And the kube proxy is just there to manage IP tables and basically route traffic properly so that when you try to access one of your containers, you can actually find it. Of course, on all the blue nodes, you need to be able to run containers, so you need Docker engine. You don't need all of Docker, you just need the Docker engine. Okay? So yes, Kubernetes uses Docker. And then there is a little bit of an elephant in the room, which is the networking. And networking is very often the hardest problem in all of this. Kubernetes takes an interesting stance. Kubernetes doesn't build the network itself. Kubernetes says, hey, I want this type of network. And the type of network that Kubernetes needs is basically a network where every pod, I'm going to explain what those are, every pod has a single IP address, and every pod can talk to each other. That's their requirement. It's very high level. So very often, you end up with a network, which is just a flat layer 3 network. And you have different network add-ons, and you'll see I'm going to use one which is called Weave. A pod, that's the lowest compute unit, lowest logical unit in Kubernetes. A pod is a group of containers, okay? So Kubernetes schedules pods. Kubernetes doesn't schedule containers, okay? Kubernetes schedules pods. And a pod is a single IP address with multiple containers inside that pod. So if you think about it, a pod actually looks like a machine, a single IP and some processes running in it. And what Kubernetes does is schedule pods on different physical servers. Okay? So it is quite, traditional in that sense. So why using Kubernetes on Oracle Cloud? Well, you're using Oracle Cloud. It's a IaaS system. You're provisioning VMs, whatever needs you may have for VMs. You're building your network there to access it and link it with your on-prem services. But as soon as you start wanting to do something with containers, you're going to need a system to orchestrate those containers. Okay? Starting the containers on a single machine, it's very easy. You install the Docker engine, and then you do Docker run. You're running containers. But when you start wanting to orchestrate containers across multiple machines in one of your Oracle networks, then you need a system. So that system, what I'm saying here is that it should be Kubernetes, and that means that now you need to install Kubernetes in a set of virtual machines that you've provisioned in the Oracle Cloud. Okay? And those machines, it's going to be at least one of those green boxes that I showed just before, and then a set of blue boxes, the worker nodes. Okay? Very much like, I don't know if you have installed Hadoop on your Oracle, account, or Kafka, or Storm, or GlusterFS. Here, instead of installing those, you're going to install Kubernetes, and then you will talk to the Kubernetes API to manage your containers. Now, Oracle recently acquired a Dutch startup called Worker, and they just came out, I think, just last week with a system called Click-to-Kube. So you should look it up, worker.com/click-to-kube, and it's very much a single binary. You use it, and it's going to create a Kubernetes cluster on the Oracle Cloud. Okay. But what I wanted to show really is show you almost the hard way. Okay. How can you set up Kubernetes on your own just by using the upstream solution? So there is nothing Bitnami in what I'm going to show you. I'm just going to show you upstream Kubernetes tools. So how do you set up a Kubernetes cluster? Well, you need to set up some networking rules. You need SSH key. You need to create instances. I mean, there is absolutely nothing new here. Okay. If you need the additional volume, you need to create storage for those volumes, attach those volumes to your instances. But up to step number 4 here on this slide, everything is normal. Okay. And then number 5, that's when you actually need to install Kubernetes once you have, those instances all set up. Okay. We've prepared a guide for you, so you're gonna get those slides after the webinar. So there is a guide here on docs.bitnami.com, and you can follow that guide. It has lots of snapshots with how to do this. So I do want to show it to you. So let's go straight into the first demo. Okay, so I need to presenter view. I need to exit that. There you go. And I'm going to go to my Oracle dashboard. So just going to give it 1 second here. So you should see my Oracle dashboard. So I've logged in into my into the Oracle Cloud. I've chosen my site at the top here, and you see we have lots of instances because I'm using the same account that Bitnami is using to run lots of tests for the Oracle Marketplace. And you see that at the top I have like 6 instances that I've started for this webinar. Webinar 0, Webinar 1, Webinar 2. And I also have master and then node 1, node 2. So to gain time, I've already set up a cluster which is made of master, node 1, node 2. Those are just Ubuntu 64 instances. So the way I created those instances was extremely simple. I just clicked on create instance. I clicked on marketplace and then search for Ubuntu instance in the marketplace. And I picked a Ubuntu 16.04 instance because that's one of the supported platform for kubeadm, which is a Kubernetes tool we're going to use. Shape, I just took the default here. So they're quite beefy, 30 GB of RAM, so they're very good instances. You give it a name. You know this, and let's specify an SSH key. So beforehand, I created an SSH key, and then network. I created a network with some rules earlier, which is called kube cluster. And then I review, and then okay, this is good. So you just launch 3 of those if you want a 3-node cluster. Okay. So that's what I've done. Now to be able to bootstrap your Kubernetes cluster the hard way, okay, there may be easier ways, and click2kube is probably cutting down on all those manual steps. But there's this setup here system that's called kubeadm. So here I'm on a web page from the Kubernetes documentation. So kubernetes.io/docs. And you can search for kubeadm, kube administration, kube being the shorthand for Kubernetes. So you have using kubeadm to create a cluster. So you can look at all the instruction here. It is quite good. So we're going to follow those instructions. And if you look at what they are, so I know them, of course, the instructions, okay, because I spent quite a bit of time. At the end of the day, here you see that there is a little bit of code on that page, which is quite basic. So you install you trust the key for the Kubernetes repository, you add the Kubernetes repository, you update, and then you see the last 2 lines. It's installing the Docker engine. And then it's installing the kubelet, which is the Kubernetes agent, kubeadm, which is the tool, and then Kubernetes CNI, which is a plugin to be able to configure a network overlay that matches the Kubernetes requirements. Okay. So, shall we take the time to do this? Yes. I think it's quite interesting. So here I have. I'm showing you a terminal where I have 3 panes. The top pane, I'm going to log into one of my instances. There you go. So that's those are instances on the Oracle Cloud. I'm just going to log in as root on all of them. I'm using tmux to be able to have those panes here, and it's quite handy. Here, so now I have 3 terminal sessions on 3 instances in the Oracle Cloud. Okay, and what I need to do is that I need to basically copy paste these instructions in all the windows. So to make this extremely quickly, I'm going to use a very nice feature of tmux, which is pane synchronization, so that when I paste, I'm going to paste in the 3 machines at the same time. Okay, because I could hear you say, oh my God, he's going to repeat the same thing on the 3 machines. No, so we have a nice feature. Here you go, already done. So I'm going to take the second one. So it's just 6 copy paste. It's not that bad. So I'm sure you can hang with me. So here you go. Now I need to create the file that contains the repository. Here you go. Boom. And then we do an apt-get update. So that's easy. Let's update. Okay, so because we added the repository. And now we're going to install Docker on those Oracle instances. Okay, so let's install Docker at get install -y Docker engine. We let the machines do its work. And then we have, here you go, the last command. And what does the last command do? It installs the Kubernetes agent called the Kubelet, kubeadm, the tool that we're going to use to bootstrap the cluster, and then Kubernetes CNI, which is a utility to configure the networking. Okay, so that takes just a little bit of time to install the Docker engine. It's worth waiting because once you're done seeing this, you're going to be like, oh, you actually installed a 3-node Kubernetes cluster in like 5 minutes. So now we do the last step of the preparation. Okay, we still need to do some things after, but it's going to be quite fast. I think it's important to see how a Kubernetes cluster can be created. Lots of people are saying that Kubernetes is difficult and so on. If you're thinking that you should run Kubernetes on your local machine, yes, it's difficult, but it's not much different than any other distributed system that we've used before. So I'm going to turn off the synchronization. And now on the top pane, I'm going to say this is my master node. So I'm going to say kubeadm init, kubeadm initialize, kubeadm init. Okay? And I'm going to let the system do its work. So what this is going to do, okay, is download some Docker images that contain the Kubernetes scheduler, the API server, things like this, and then it's going to start the kubelet, which is the agent, and that kubelet is actually going to look at some file manifest, and it will start the other Kubernetes components. Okay. So we're gonna let that go, and then I'm going to jump to just a quick demo locally. Actually, I should have started with this one. If you are trying to get started quickly on your local machine, there is a system called Minikube. You can install Minikube on your laptop. It also runs on Windows, so that's quite easy. So here I have Minikube running. That means that I have access to a Kubernetes cluster. And the first thing I can do is kubectl get nodes. Okay, and it gives me an answer. kubectl is the command line client to talk to a Kubernetes cluster. So when I issue this command, kubectl get nodes, I'm actually talking to the Kubernetes API server that's running on my local machine. And it returns saying, hey, there is one node available to you. It's called Minikube. Now remember I said that Kubernetes has scheduled pods, the lowest logical unit. And here if I do kubectl get pods, it tells me there are no pods. So let's run some pods. So we're going to run Ghost, a microblogging platform. So there is a very nice wrapper with the kube control client. So I'm going to say run Ghost, image Ghost. And that image comes from Docker Hub. So I'm going to do that. And then I'm going to say that I want to expose this deployment, this application deployment called Ghost. I'm going to expose the port 2368 because that's where Ghost serves on, and then the type is node port. Okay, just 2 commands. Now, when I do get pods, it's saying, aha, there's something that's creating. Okay? So what's happening here is that Kubernetes is now actually downloading the Docker image, Ghost. It's pulling it from the Docker repository, and then it's going to run that container, inside some wrappers that's Kubernetes specific, and then we'll have access to it. So we can actually put a watch here. While this happens, yeah, we're multitasking. Let's go back, and here you see that we have our kubeadm init in our Oracle Cloud that has finished. So I'm going to copy some of the lines that are here as output. Those just set up some configuration, okay? And then if you look, there's one line that's crucial at the end. It says you can now join any number of machines by running the following on each node, okay? This is the way to bootstrap the system. So I'm going to go to the first node and then just paste the command. I'm going to go to the other one on the right, paste the command. So what's happening now is that my master node at the top is all set up and running. And then the two nodes at the bottom, here you go, you see it's done. I've issued a command which is join. So the two nodes at the bottom, I've said, hey, join the master. So now at the top, if I do get nodes, here you go. You see that I have 3 nodes. I have the one that says 2 minutes, which is my master node, and then I have the 2 nodes that just joined 15 seconds ago. Those are my 2 worker nodes, okay? The status is not ready. The status is not ready because we do not have a network, okay? We didn't do anything with the network, nothing specific. We didn't specify any security rule, anything. We're going to create an overlay. So we scroll down in the documentation and we see installing a pod network. So I'm going to click on this link here to the add-ons. So there are different network plugins available. Calico, Canal, Flannel, I mean, you name it. There are several add-ons. One that I like is Weave. And honestly, the biggest reason I like Weave is because there is a single command that works every time. So here it's a command that actually uses Kubernetes itself to install the network. It's kubectl. It's this Kubernetes client apply. What this apply does is that it's going to look at this URL, https git.io, blah, blah. And in this URL, there is a manifest. It's a lot of YAML. It's a manifest of Kubernetes objects to create. And when Kubernetes creates those objects, a little bit magically, in that case, it's going to create a network. So here I have started things, and now look, I'm going to put a watch on this. And what's going to happen is that once the network is established, the nodes are going to be able to start talking to each other properly. And then the nodes are going to enter a ready state. Okay? The magic that's happening here is that this single command, kubectl apply, is going to launch containers on all the nodes. Those containers, and this is going to be a little bit technical, but those containers share the network namespace of the hosts, and then they use that plugin, that Kubernetes CNI, to actually configure the network bridges properly with the proper CIDR of the network and so on. So we are using Kubernetes itself to bootstrap the network. And now here you see my nodes are ready. So in 10 minutes, and that's because I talk a lot, we bootstrapped a Kubernetes cluster from scratch by creating instances on Oracle Cloud. Okay. Now, if I go back to my local setup here, I have Ghost running, and I can open the application Minikube service Ghost, and oops, here you go, and that's opening up the Ghost application that I just started. Okay, this might look like a lot of magic, but so let's go back to the terminal. and hopefully there's not too much lag. So when I talk, you actually see what I'm talking about. And we can do the same thing in that Oracle-based Kubernetes system. kubectl run run ghosts -- image equal ghost, and then kubectl get pods. We put a watch, and same thing here. It's going to download that ghost image. Okay, and then we'll have ghost running inside our Kubernetes cluster, inside our Oracle Cloud. Great. So now let's go back to the presentation a little bit, and let's talk. I haven't talked much about the Kubernetes, the Bitnami specific tools. So Bitnami, we have been very involved with Helm, which is the Kubernetes package manager, and then we've developed a system called Monocular, which is basically the Docker hub of Kubernetes. So when you want to access those Kubernetes applications that you've created, or if you want to access Kubernetes applications from other people, you can use Monocular. Okay? It's just an application discovery and also launchpad, because we are very good at doing launchpads. So that's what we do. We can launch applications. So that's Monocular. I'm going to show it to you. On the left, you see a slide. There is actually a public version of this. So if you go to kubeapps.com, you'll see the hosted version of kubeapps, which in this hosted version is just purely a discovery mechanism. Okay? But there is an in-cluster experience. And what does that mean? It means that you can run this discovery, this package discovery system. You can run it inside that cluster that I just created. So if you start using Kubernetes in the Oracle Cloud, then you can install Monocular, and you can start launching your own Kubernetes packages, and we can help you create those packages, of course. So that's Monocular. So let's have a look at Monocular. I've created before another cluster, okay? So exactly the same way, but I've started a few things before, and I've lost the connectivity. That's what happens. I've lost the SSH connectivity with the. Let me try to. Okay. Let me try to recover from this. Okay. Here you go. So I'm going to. I just lost the SSH connectivity with the node because it was up for too long. So now I'm on the node where I've started lots of things. Okay. So let's do a get pod, and we're gonna see many different things. You see that I'm running at the top. I have a ghost pod, so that's the example that I just showed you. I have something which is called an NFS provisioner. That's a way for me to be able to provide data volumes, okay, to all my containers. So there is a good advanced story where we can talk about storage. And then Monocular here is running. It's running inside my cluster as pods themselves. And the way that we can access Monocular, how do I get this out? I need to exit the presenter view. Okay. So, and now you see Kubeapps, which is the online version. So you see lots of those Kubernetes packages, those charts that have been contributed by the community, and Bitnami is one of the leading providers of charts. But if you run Monocular, notice the IP address. This is a public IP address of one instance in my Oracle Cloud, and I just created a security rule to be able to access this system. So this discovery, mechanism is actually running inside my Kubernetes cluster within Oracle. So what you do with this is that you can browse those repositories of application. You see all the documentation for the application. You see all the versions. And then, in that particular case of this instance, it's actually a copy-paste mechanism, which is a little bit, low tech. But the advanced version of the system has a direct deployment from the UI. So now I copy-paste the command, and when you run it, Helm install, the system, what you end up with is that this is taking that package that we have referenced and that we've discovered from the UI, and now you're installing it inside the cluster. It's very much like apt-get install or yum install or brew install, all those package management systems. So here you have the same thing for Kubernetes. Helm is the package manager for Kubernetes, and Monocular, developed by Bitnami, is the way to be able to browse the repositories of packages and be able to launch those systems. And in development, actually in a development branch, we have the ability to directly trigger the install from the user interface. Okay. Now another system that we have, it's called Cublas. So I mentioned at the beginning that applications were evolving from bare metal to VMs and then containers, Kubernetes packages, and definitely these days there is something that's coming up, which is serverless. So serverless is very much about writing very small snippets of code and being able to deploy that and link services together. People call that FAS, function as a service. And we can argue about naming and so on. The amazing thing is that Bitnami has developed a system called Cublas, Kubernetes Serverless, which is all open source in github.com/Cublas. And you can install that system inside that Kubernetes cluster that you have in Oracle. So suddenly you now have function as a service in Oracle, thanks to Bitnami Cublas. Okay? And here there's just a basic example of a function that we've created from a CLI, and you can modify the function, you can view logs, and here I'm just going to do a basic example. Hello Oracle, you can fill in some basic parameters, and this is really much for development. There you go. So I just send a request to my function. And what's happening here is that my function is actually deployed inside a container that's running inside a pod managed by Kubernetes. Okay? So what you're seeing here is that if I do a kubectl get pods in something that's called all namespaces, let me try to see if I can. Yeah. There you go. And that will be the last thing I want to show you is that if you look at what's now running inside my Kubernetes cluster in my Oracle Cloud, you see that I have Ghost, I have my Monocular, and here my function that I've deployed, you see that it's also a function that's managed by Kubernetes. It's this post-python. That's what Cublas gives us. It enables us to deploy simple functions directly inside containers without building them. And the namespaces, it's a little bit of, it's a way to basically isolate the names of services. So here you see that there is a default namespace at the top and then a kubesystem namespace. And in that kubesystem namespace, you see lots of things. If you're curious, you see the networking, like those WivNet pods. So all those are pods, okay? So they're containers. So you see that the network is implementing through containers. The Helm package manager, it's enabled by this chiller thing. I was able to access all the UIs that I showed you because there is an ingress controller running. And then you have things like the scheduler, the proxy, a DNS system, an API server. All of this is running as Kubernetes pods and managed by Kubernetes. At the bottom, you see a Cublas namespace. So that's how we deployed Cublas. There is a controller, and then the UI that I just showed you is accessed because it's running inside a container. It's a node application running inside a container managed by Kubernetes. So that's it. I think I just spent too much time showing you the basics of Kubernetes. But what's going on? Why can I? Okay, I'm trying to. But look at Monocular and Cublas as great tools to deploy your applications inside your Kubernetes cluster. Check out our documentation to see how you can create that Kubernetes cluster in your Oracle Cloud. There are lots of details about the security list, the security groups, the security application, how to do data volumes, and so on. All of those details are in our how to Kubernetes on Oracle. Okay, so you'll get those links. Just ping me by email or ping me on Twitter, and I hope it was interesting. Thanks a lot, guys, for listening. Little bit long today, but hopefully it was interesting. And back to you, Mavian.
Great. So thank you, Sebastien, for that presentation. It definitely was interesting. I'm going to go ahead. We can just go ahead straight into live Q&A. I'm going to leave these references up on the screen so that way anybody that would like to take a look at the documentation or the particular GitHubs for the Bitnami container tools, they can go ahead and take them from here. I know somebody was asking for Seb's contact information, so you can reach him at sebgoa@bitnami.com or at sebgoa on Twitter. Let me see what questions we may have. I know.
Mavian, I can walk down through the questions if you want relatively quickly.
Sure.
Yeah. Can Kubernetes use a different container platform like Rocket? Yes. By default, it will use Docker, but it can use Rocket. Do you know of any customers that are running this in production? Yes, I do know of customers. Lots of people actually are starting to use Kubernetes in production. Can't really give you names, but well, okay, Ricardo.ch in Switzerland, Playtech in the UK if you want, and then of course in the US, lots of things. You'll get the recording. Yes, we'll give you the link on the serverless. It's github.com/Cublas. And for runtime, we support Node.js and Python, and a little bit of Ruby.
Okay. Does that cover all the questions?
Yeah, almost. Yep.
All right. Well, I want to thank all of our attendees for joining us today, and Sebastien as our speaker. For those that want to listen to this or watch this again on demand, feel free to check your inbox. In about a day or two, we'll be able to give you those resources from this last slide, as well as the on-demand link on our Bitnami YouTube. Again, thank you, everyone, and I hope to see you at our next webinar.